Hello everybody, welcome back to my channel. Today we are going to talk about linked list and related problems. Before we start, I request you to subscribe and press the bell icon on this channel. It will help algorithm to find my channel and this video. I'm putting all the sections with the timestamp in here. If you want to jump directly on the topic, you can directly go. Or if you want to go, if you think the video is slow, then you can increase the speed and finish this video early. But I request you to watch the entire video. It will help algorithms to find my video. So let's get started. The linked list. Linked list is connected nodes. So each node will have a two section. One is the data itself. Second will be the reference to next node. Each node of the linked list will hold the reference of next node. So we will move forward only once we start with nodes. If we start with any nodes, we can just move forward and following nodes only. We cannot go in back if it is a singly linked list. So let's see and dive into the linked list, what kind of the linked list are and what type of linked list are available. So this is linked list. I will say there are three different type of linked list. One is singly linked list. In this case, so this is our node, and each node have a two section, data and reference, and this node reference section will keep the reference of this node. So when we have this node available, so we will find the next node, and then we'll find the next node, and then we'll find the next node. That way we'll keep going until we reach the reference null. So that's how we will traverse through the linked list. Second is doubly linked list. In this case, each linked list node will have a three section. One will the reference to previous node, data, and then reference to next node. So that's when we start. If you want to go forward, then it will keep the reference this one, this will keep the reference this one, and this keep the reference this one. And if you want to reverse back, so this section will keep the reference of this one, this section will keep the reference of this object, and this then vice versa. So we will go. And secondly, in both the type of linked list, we have a singular linked list, singly linked list, and doubly linked list. We will have a circular option. So this node, last node, if it is in last node null, if last node keep the reference of first node, then in that case it will circular linked list. So this is similarly in that case, because it's the last one, it will, if keep the reference of this one, then it becomes doubly single list, and this one will keep the reference of this object. That is why it will singly doubly linked list. So mostly we will right now target only single linked list problems. So let's get started with first problem. The first problem is removing duplicate from a linked list, and there are the two types of solution we are going to talk about here. One is with a third-party variable, or you can say buffer, and one is without buffer. So let's jump directly to the algorithm. So let's first discuss the solution 1. So let's get a solution 1 is that in that case we are using buffer. So in this buffer in Java we are going to use the hash set. The hash set in an example where we cannot keep the duplicate one. So we will keep we traverse through the linked list and we'll keep adding those there's value in that hash set. And if there's a difference, if that we already find this one, so when we start traversing from node 1, we'll check if the data contains in the linked list in this hash set, it means we already found in previous nodes, so it is there. It means we will jump directly to next one. So we'll remove the next node and point the next nodes next to the next one. So in this case, for example, we found the 2, we'll go to 3 because we did not find, so we'll add this to set and move the next node, then we'll move next one. Then it means we'll see this we found this 2 in the hash set already. Hash set means what will happen in that case, whatever this 2 is referencing, it directly refers to this one. Now we'll move to the 4 if check 4 is there already in hash set, no, then we'll add the 4 in there and move the next one. Then we'll check if 5 is there or not, then we move, because 5 is not there in hash set, we'll move next. And then we'll see this 3. So 3 is, when we check in the hash set, we already have 3, so we will move what we'll do, whatever 3 is referencing, next we'll reference here. So ultimately we will have a 2 3 2 3 4 5 and 6. This is how we are solving this problem. So now go to solution 2, where we don't need a buffer. So that way, so here we have a space 1, O1, we still an O n time will traverse O and time, and but we also considering a space component. But in this case we are not going consuming any space, but we are doubling, means it travels O n square time. So let's see here how does it work. So we have a current node, this is our current node, C node, this is our 2, and then we runner we make 2, okay, say first node, and then we'll start the next. If current data matching with the runner's next data, this is the runner, so we'll start if runner's next data, runner's next is 3, so matching, if matching, then we'll move this to here, but in this case it's not matching, so we'll go compare 2 to 3 with this one 2, and now 2 and 2 are matching, it means this is duplicate, so we will point this reference to this one. Then again runner will go to 4, because now 2 is 4 is 4 is matching, not matching with the 2, then we'll move next one. If 5 matching with the 2, no, then 2 matching with the 3, no, and 6 matching with 3, 2, no. Okay, so this is one round. Now we'll start with second one, and runner will start from here only 2. So 3 matching with, now we don't have in the linked list, 2 is not there, cut. Now we have this one. So 4 is matching, no, then 3 will go to 5 matching, no, and then because 3 matching, so it will point this 3 to 5, and this will completely gone. So now this way will start. So now next is 4. This is how we will remove the duplicate, and that's where the loop is running n square time. So running time is more, but it's taking less space compared to the previous logic. Next problem is finding the kth element from the right of the linked list, and we will be given the head of the linked list. So how we are going to find the last element, means kth from the last element, and that's where recursion comes into picture, because we cannot find that way which will be the last, because until we iterate to each one we still not find the last one, and because we are not pointing to previous one, so we have to do the recursions. So let's come to the solution. Three different solutions we are going to talk about here. The one is printing the value with the recursion. Right, let's jump into the code and the algorithm. Kth element from right. So this is the recursive method we are doing. So this is the link. Suppose we want to print the third character or third character from the right. So we will start the number 4 and number 0s, and then we'll check head is the beginning point, and we'll check if head is null, means first node itself is null, then we return 0. Second, then we'll start check again, we'll run it and pass it whatever recursion value we received, we will add into it. We keep incrementing. So what is happening, this code will run till all the way in the end until we have a last element received. Now when then each iteration start giving result, it will keep adding until index will become from the equal to k, and that's how we know that this is the kth element of that one data. So we just keep doing 1, then go all the way till reach all the way till, so by the time index will be 0, when it will this second previous iteration then it will be 1, then 2, then third. This is how it will be null, then it will be 1, 2, 3, 4th. That way we know the 8th it will the output. I hope I was able to make this clear. Now let's go to second method where we will get the value rather than printing, because here it is not returning, it is printing. So next solution, here was printing. So again, for this purpose we have to create a class index class, because it will track the index, and if we pass the index in the method, that way we know it will keep incrementing that value. Logic is almost same. This is null value, this is the kth element we want, this is the index which will track the index, and this is the starting point. If head is equal to null, then it will return null, and then it will keep return null, and if then it will execute the previous iteration, I mean second last iteration, it will add 1 here, and then keep doing, and then return the object, and again it keep doing it, and that way in the last we will have a, when the value of index is equal to k, in that case value index of value, this is our iterator, so this will add here, and if it is a head, it means that is the object we are returning. So this way we are returning the object. This third logic, it will be iterative, it will not be recursive. So we will be, when it will be even more efficient, because here we are not recursive, so it will not use that much of a space, that will use the less space. So let's see how this is going to work. Here we have 2 node. We'll start with the head 1 head and p2 head from first one and second 10. Then first we'll iterate until I to the kth element for p1, and then we'll start iterating each parallelly. So till the p1 become null, p2 will be at the kth element. So just take an example here. We have a I, and then we have a p1 and p2. Okay, when I is 0, p1 will be, as per this logic, it will be 2. When 1, it will be 3. When 4, it will be 5, means it will be 4. Sorry, it will be 2, it will be 4, and then at the same time p1 will be the 1. When 5, it will turn to 5. Then we'll come to this next loop, and until the p1 become null, we'll do it 5 equal to 1 equal to p2 equal to 2, 5 equal to 6, p2 equal to 3, and 7, 4, 8, it will be 5, 9, the P1 will become 9, and P2 will be 6. When P1 equal to 10, it will be 7. It means we reach till here. But when P1 become null, 2 will be 8. So that's where we receive the third element from the right hand side, or from the bottom. So this particular logic is more efficient compared to last two recursive one. So next algorithm is deleting a node, a value from the linked list. So we have a linked list and we are asked to delete a node. That node can be anything. We were given this node to delete from our linked list. So how we are going to do it? Let's look at the code and understand how it's going to work. It's very simple. We were given a particular node number n. For example, we are given the node number 4. How we are going to delete? So same thing, if n is equal to null, or the assumption here is first and last node we are not going to delete. We are going to delete only middle node. So if it is the next equal to n equal to null or n equal to null, then we are not deleting anything, return false. But if middle, then we'll keep. So it means we have a node number n. So we have a number, for example, we are deleting, so we have a 4. 4 is referencing to 5. 4 is referencing to 5. So we will keep the next value 5 here, n equal to 5, next equal to 5, it referencing to 5, and now this n, what we are going to do, we are going to copy the data of 4 into 5, and then we are going to refer the reference of 6 to here. So two things next node's value will be stored into node n, because we have access to for node 4. We don't have access to previous nodes. We only can go forward. So if we want to delete, what we are going to do, rather than because we don't know what will be the third one, previous node, so we just have to copy the data from node n, and then we are going to point this next node to this one. That way this data is completely kind of eliminated in the list, kind of deleted. In the next video I'm going to discuss 3 more algorithms related to linked list. Please stay tuned and subscribe my channel and provide your feedback and thumbs up the video so algorithm can find these videos and many people who and it can reach to many people. So thank you very much for watching till the end, and hope I'll see you in the next video.